Okay, this is a difficult question. With this process we learned, we're going to have to convert everything to moles, but then we're given a multiple choice type answer. So we're trying to figure out which is the best answer here. Not like in this one, we don't like those. I don't even know if that's 2 times 5 or 2.5. But let's figure this out. So remember, we talked about if you have percentages that you can convert those to assume a 100-gram sample, because what we want to do for each one is start in grams of that specific atom and then get to moles. Then we're going to divide by the moles of the least amount and figure out our ratio. So let's clear this. Okay, so I'm going to write 58.8 grams of carbon, 9.87 grams of hydrogen, and then the rest is oxygen, right? So we're going to go 100 minus 58.8 minus 9.87, and I get 31.3 grams of oxygen. Now I got to get to moles, right? So I got to multiply by the molar mass and flip it upside down. So carbon is 12.01. So I'm going to say times every 1 mole of carbon has 12.01 grams. I put these kind of close together. Every 1 mole of hydrogen has 1.01 grams. And every 1 mole of oxygen has 16.0 grams. Now remember, we got to do the molar mass of each one. We don't divide them all by 12 or all by 1. We got to divide by its particular molar mass. So 58.8. So I get divided by 12.01, I get 4.90 moles of carbon. I get 9.77 moles of hydrogen and 1.96 moles of oxygen. Okay, so now we're in a molar ratio. Now remember, a molar ratio is just like if you're looking at one independent molecule, what's the atom ratio? We can also consider that moles. So if we have 1 mole of a molecule, what is the molar ratio of the atoms? Because we're looking for empirical formula. We don't know the molecular formula based off this information we're given, just empirical. What is the lowest ratio of carbon to hydrogen to oxygen? Okay, so I'm going to divide them all by 1.96. Just to normalize them here. And here I get 2.5. Here I get 5. And here I get 1. Now, so that's where this 2.5 comes from, but we want whole number ratios because we want to think about it like a molecule, right? We can have 2.5 atoms to 5 atoms. We got to have whole number atoms, so we like whole number mole ratios as well. So I'm going to multiply all these by 2. And so I get a 5 to 10 to 2 ratio, which I see represented here in B. There we go. Now, if I had the molecular mass, if it told me the molecular mass, I would figure out, well, what is the molar mass of the empirical formula? So I'd add up 5 carbons, 10 hydrogens, 2 oxygens. So that's about 60, 70, 102. And so if it told me there's 204 grams per mole, I would realize, okay, the molecular formula is 2 times this. So it'd be C10H20O4. And so that's that next step to find molecular formula. But here we're just looking for empirical formula. So we're going to select B. There we go.